Hello, good day viewers. In this tutorial, we are going to answer some bunch of questions here that are all under circle theorem. We are given a circle here with many angles inscribed. We have the following questions. All right. We are asked to use the diagram above to answer the following questions. We have the first one, which reads, which chord sustains an angle ABD? So let us locate ABD. This is A, this is B, and this is D. So let us connect them together. We have A, we have B, we have D. So we are talking about this particular angle. So the question stated that which chord sustains that angle? You can clearly see the chord here. This is the chord AD. This chord AD sustains an angle to the circumference to form angle B. So therefore, the required chord is chord AD. So let's write it here. This is chord AD. And hence we have just answered this one. Let us move on to the next question. The next question reads, name an angle equal to ABD. ABD. All right. You should know that all those angles subtended by the same chord will be equal. So since chord AB subtends this angle, then any other angle subtended by the same chord to the circumference will be equal. So you can see we have another one here from AC to D. You see the same chord AD subtends these two angles, so they must be the same. Let's see whether we have another one. Yeah, we have another one. The same chord AD subtends an angle to E. Can you see that? So we have these two angles. Initially, this is what we have. Then we obtain these two. ACD. Let me write it first. We have ACD. Then the next one is AED. AED. So these two angles are the same with this one. Let's move on to the next question. Question number 3 reads, which arc sustains an angle BEC? BEC. BEC. So we're talking about angle E right here. So which arc sustains this angle? This is the arc BC. Arc BC. So let's write it here. Arc BC. Then the next question reads, name two angles equal to BEC. All right. We want to find other angles that are equal to this particular angle right here. So all other angles subtended from the same arc will be equal. So let's see whether we can find them. We have another one here. Can you see from arc BC? Do we have another one? Yeah, we have another one here. Can you see that? From the same arc. So these two extra angles must be the same with this one. So let us write them. We have BAC, which is this one. BAC. Then we have BDC. BDC. So these two angles must be the same with this one. Next question. Name an angle in a segment opposite to that which contains ADC. Remember what is a segment? A segment is a region bounded by the arc and the chord. So now let us locate this angle ADC. AD is this one, ADC. So we're looking for angle opposite to this one. So this angle D is in this segment, which is bounded by this chord and this arc. So which angle is opposite to this one? The angle opposite to that one is this. Look at it, ABC. This particular angle is opposite to this one. So the answer is ABC. Angle ABC. Next, name three angles which are half the size of COD. Let us find COD first. CO, the center, D. COD is an angle subtended to the center by the chord CD. So any angle subtended to the circumference from the same chord will be half of this one. So you see, we have an angle here subtended to A, which is part of the circumference. And we have, and let me write this one first so that we will not complicate the issue. So this angle is twice this one because angle to the center is twice the angle to the same circumference from the same arc or chord. So we have CAD. CAD. So now let us find the next one. If you observe, the same chord CD subtends an angle to the circumference, which is E. So this angle will also be the same with this one, and all of them are half of this. So the next angle is CED. CED. Next question. Name all the right angles in the figure. Remember that a diameter subtends a right angle to the circumference, and we have two diameters here. We have one diameter here. I will start with this one. So any angle subtended by this diameter to the circumference would be a right angle. So one is here, this particular angle, which is what? EBCOCBE, all the same. CBE is a right angle. Then we have another diameter here. This is a diameter. Line BD or chord BD is a diameter and it subtends an angle to E. So this particular one here is also a right angle, which is BED. BED. So these are the two right angles we have in the figure above. What kind of quadrilateral is BCDE? BCDE. Okay, we are talking about this quadrilateral. This quadrilateral is a cyclic quadrilateral. So we have cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral which is inscribed in a cycle and all the vertices are touching the cycle. You can see it has 4 vertices. All of them are touching the circumference of the cycle. So it is a cyclic quadrilateral. Then if angle BOC is 70 degrees, let us locate it first. BOC. BOC. So if this is 70 degrees, then what is the question? What is the measure of angle BAC? BAC. BAC. All right, you can see all of them are from the same chord BC. So chord BC subtends an angle to the center. The same chord subtends another one to the circumference. So that angle subtended to the center is twice the angle subtended to the circumference. Therefore, if this is 70, this will be 35, which is half of 70. So this is 35 degrees. Next, if angle CED is 57, let us locate it. CED, this is 57 according to them. So what is the question? What is the measure of angle CBD? CBD. CBD. We're talking about this particular angle. Let me call it X. If you observe, both this angle and this one are subtended from the same chord CD. Therefore, they must be equal. This must be 57 as well because all of them are subtended from the same chord and all of them lies on the circumference. So the two angles must be the same. So this is 57 as well. The answer is 57. Second to the last question, if angle BAE is 126, let us locate it. BAE, we are talking about this angle. Is it 126? Let me confirm. Yeah, 126 BAE. We're asked to find the measure of angle BDE. 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 All right, this is a cyclic quadrilateral. And in cyclic quadrilateral, opposite angles are supplementary, meaning if you add them together, you're going to get 180. So we're looking for this particular angle. It will be equal to 180 minus 126, which is equal to 54 degrees. So that angle is 54 degrees. 54 degrees. Then the last question, if BOE is 140, let us locate it. BOE, this particular angle, they say is what? 140 degrees. 140 degrees. Then we asked to find the measure of angle BAE. BAE. We are talking about this particular angle. Let me call it X. You should know that this is not a cyclic quadrilateral because only 3 vertices are on the circumference. This is on the center, so it is not a cyclic quadrilateral. Otherwise, we say that these two angles are supplementary. But remember that angle subtended to the center is twice the angle subtended to the circumference. So if we should form an imaginary angle here, this particular angle will be 70 degrees. Why? Because angle subtended to the center, which is 140, must be twice this one. All right, if that is the case, remember that we have now formed a cyclic quadrilateral, which means that X and 70 together will give us what? 180. So therefore, X plus 70 is equal to 180, which means that X is equal to 110 degrees, right? This is one way to do that. Let me write the answer before we come back. I will show you another alternative. This is 110. And another way you can do this is that if this angle, which is right here, is twice this one, then this angle at the back will be twice this one, right? So what is this angle at the back, which is reflex angle? Remember that angle at the center is 360 degrees. Therefore, this will be 220. And this 220 will be twice this one. And if you divide 220 by 2, you shall obtain 110. So that is another alternative. And we have just answered all the questions. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.